The algebra of functions. So you can perform algebraic operations on functions just the same way you can do on numbers and variables. You can add them, subtract them, multiply them, and divide them. And they work just like variables. The main thing you have to watch out for is when you divide them, make sure your denominator doesn't equal 0. Okay? So let's do some examples. So if I'm given that the function f is 5 times x minus 3 and the function g is x squared plus 2, let's find f of f plus g of x. That means add the functions together. Okay, so it's going to be 5x plus 3 plus x squared plus 2, and we will get x squared plus 5x plus 5 equals our f plus g of x. Okay, b, let's subtract them. So f minus g of x is going to be 5x minus 3. Oh, I made a mistake up there, didn't I? It should be a minus. So that's going to change that. Glad I caught that. That's going to change that to a minus 1, isn't it? Come on, pen. There we go. Okay, back to subtracting. So I have 5x minus 3 minus, and I'm subtracting the entire function, okay? So put that in parentheses. Now that's going to work out to 5x minus 3 minus x squared minus 2, and we get negative x squared plus 5x minus 5. Okay, C, f times g of x. Okay, f times g of x is going to be 5x minus 3 times x squared plus 2. Let's do FOIL on that. First terms give me 5x cubed. Outside terms give me 10x. Inside terms give me minus 3x squared. And last terms give me minus 6. Okay, and finally, f divided by g of x. Okay, that is going to be 5x minus 3 divided by x squared plus 2. And there is no value of x, no real value of x, that will make our denominator 0, so we can leave it. We're safe. Domains. Well, basically you want to go with the intersection of the domains of your two functions that you're operating on, okay? So the domain of f of x is x minus 2 must be greater than or equal to 0, so x is greater than or equal to 2. The domain of g is all real numbers, since it's a polynomial. Well, the intersection of greater than or equal to 2 and all real numbers is greater than or equal to 2. So that will be the domain of f plus g, f minus g, and f times g, and f divided by g. It will all be x is greater than or equal to 2. Now with f divided by g, you would also need to make sure that g would not ever equal 0, and since it's x squared plus 3, there are no real values of x that would make that 0. So this is the domain for all of those new functions. Now let's evaluate some of these. So if I want to know what f plus g of 2 is, okay, I can just go like this. F plus g of 2 is going to be f with 2 plugged in plus g with 2 plugged in. And I get 4 minus 16 plus 4 plus 8. That's negative 12 plus 12. I get 0. Okay, f times g of negative 1. Okay, let's do negative 1 squared minus 16. That's f with negative 1 plugged in times 2 times negative 1 plus 8. That's g with negative 1 plugged in. Okay, so I get negative 1 squared is 1, minus 16 is negative 15, negative 2 plus 8 is 6, And negative 15 times 6 is negative 90. And finally, f divided by g of 3 is going to be 3 squared minus 16 over 2 times 3 plus 8. That's going to give me 9 minus 16 over 6 plus 8, which is negative 7 over 14, which is negative 1/2. Now there's another way you can do this. You can go ahead and figure out what f divided by g of x is first, okay? So that's x squared minus 16 over 2x plus 8, and I notice we can factor that. So I'll do that on the top, and I'll do that on the bottom. And now I can cancel, and I get x minus 4 equals 2. So that means that f over g of 3 would be 3 minus 4 over 2, which is negative 1/2, which is the same answer we got doing it the other way. You can pick either way you want. You can figure out the new function first and plug the numbers in, or you can plug the numbers in and work it out. When we have a composition of functions, that means we're going to put a function inside a function. And here's how the notation works. F circle g of x means take the function g and put it inside the function f. G circle f of x means take the function f and put it inside the function g. So here's an example. If this is my f function and this is my g function, then g circle f of x means take f and put it inside g. So that's going to be, let me write this out, g of f of x is going to be twice the f function plus 1. That's what g tells me to do. That's going to be 2x squared minus 6x plus 1. And that's it. We can't make it any simpler than that. Now b says to do f circle g of x. That means take the function g and put it in for x in f. So here we go. That's going to be 2x plus 1 squared minus 3 times 2x plus 1. All right, let's do FOIL on this. That's going to give me 4x squared plus 4x plus 1 minus 6x minus 3. And we'll combine similar terms. 4x squared minus 2x minus 2. And that is f of g of x. So how can we evaluate a composite function? Well, if I want to know what f circle g of 3 is, then I'm going to do g inside f, right? So let's get that first. F circle g of x is going to be 2 times x squared plus 4 minus 7. That's 2x squared plus 8 minus 7, which is 2x squared plus 1. Okay, so now we're ready to do f circle g of 3. That's going to be 2 times 3 squared plus 1. That's 2 times 9 plus 1, which is 18 plus 1, which is 19. And our last topic is the difference quotient. Now, if I have this quotient right here, f of x plus h minus f of x all over h, that's called the difference quotient. And we use that to get the slope between the points x plus h, f of x plus h, and x, f of x. All right, so here we go. Determine the difference quotient of this function. So f of x plus h is going to be x plus h squared minus 9, which is going to be x squared plus 2xh plus h squared minus 9. So now we're ready to do the difference quotient. F of x plus h minus f of x all over h is going to be this whole thing minus that all over h. You ready? X squared plus 2xh plus h squared minus 9 minus f of x. I'm subtracting the entire function, so I'm going to put it in parentheses over h. Now let's combine similar terms. you'll notice that I have an x squared and a minus x squared. I have a negative 9 minus a negative 9. So all I have left on top is 2xh plus h squared all over h. I'm going to factor an h out of the top. And I'm going to cancel those h's. And my difference quotient for this function is 2x plus h.